Okay, so if you were struggling with the first video, most likely your struggle was just determining, what's my outer function and what's my inner function. From there, we can basically break it up into pieces like I did in part A and find, my outer, the derivative of my outer, the derivative of my inner, and sort of compose them together, and from there form the derivative, kind of like what we were doing yesterday, or I should say today. But what we want to do now, because this may be a little bit easier for you to visualize as far as how the chain rule goes, and it's also going to be a lot faster, because when chain rule gets more complicated than these examples that I give you, there will be a lot of different steps and a lot of different rules to apply, and so it might be hard to keep track of everything if you're writing out like h of x, h prime, g of x, g prime, plugging it in, things like that. So how do I do it so quickly, so naturally? So this is what I do. I have here how I visualize the chain rule. And so it's still very important what I'm telling you in the top of this handout, and you can absolutely use it tomorrow as far as getting some class practice with finding the derivative using the chain rule, is that you still need to know the formal definition of the chain rule. So you still need to know the derivative of f of g of x is f prime of g of x times g prime. Okay, but here this is where I'm telling you I just sort of visualize in my brain parentheses to a power. And so wherever I say like the word parentheses to a power, I'm talking about whatever's inside of the parentheses is a function. Okay, so in my brain, it doesn't matter what the function is, I'm just picturing parentheses to a power, and I'm saying the derivative of that is I need to bring down my power, copy the parentheses to the power minus 1 times the derivative of the parentheses. And so in other words, you can see here that in reality, I'm taking the derivative of my outer function with my inside left alone times the derivative of my inner. Because when you see this parentheses to a power, does this remind you of something? Hopefully you tell me this reminds you of the power rule, except the power rule tells you the derivative of x to the n is equal to n x to the n minus 1, where x is your variable, right? So we just had a variable x. We didn't have a function like, I don't know, x cubed plus 5x plus 1 raised to the third power, for example. And so that's what I'm talking about when I say parentheses to a power versus just the variable x to a power. So hopefully this visualization helps you a little bit. And so here in this handout, I also include an example of what I'm talking about. So here you see that I have f of x is equal to x to the 4th plus x to the 20th. Okay, so here I'm picturing my parentheses to the 20th power, or parentheses to a power. So I bring down my power, I bring down that 20, copy the parentheses to the 20 minus 1, which is 19. And then times the derivative of what's inside of my parentheses. Okay, so what I get here is the derivative of x to the 4th plus x. That gives me 4x to the 3rd plus 1. And so I'm explaining to you, since 4x to the 3rd plus 1 is the derivative of what is inside of the parentheses. Okay, and so looking at this too, I can do this more not just with parentheses to a power or a function to a power. I can do this also with other functions as well, like e to the parentheses or e to a function. We had a rule generally, right, like the derivative of e to the x is just e to the x. But what's the difference with e to the parentheses versus e to the x? Well, e to the x, my x is just a variable x, whereas parentheses, what I'm talking about is it's a more complicated function than just x. It's like x squared plus 1 or 2x plus 5 or something of that nature. And so when I want to take the derivative of e to the parentheses, I'm saying that it's the derivative of that is just e to the parentheses times the derivative of the parentheses. And so you can see that I am taking the derivative of my outer function with my inside left alone, right? Because the derivative of e to the x is just e to the x. So in other words, the derivative of e to the parentheses is e to the parentheses, but now I'm multiplying by the derivative of my inner function, which is the parentheses there. And so again, I give you some examples of what I'm talking about here. Like suppose my function is e to the x to the 5th plus 5. I'm overemphasizing the parentheses in this case with this function, because most likely you wouldn't see it with these parentheses here. That's what I'm talking about. Okay. But if I want to take the derivative of that, what I picture in my head, I just picture like e to the parentheses, and I'm like, okay, what's the derivative of e to the parentheses? Well, it's just e to the parentheses times the derivative of the parentheses. And so this will make a lot more sense when I'm doing more of these examples out, but I just wanted to give you a quick handout and show you how I visualize the chain rule, because the visualization kind of gives me almost like a shortcut of computing the derivatives of these functions using the chain rule. And so on the right here where I wrote in black, I'm just showing you that that's what my outer function is, the derivative of my outer with the inside left alone. And that's where I'm getting these like rules, so to speak. So in reality, you don't really have to necessarily memorize all of these things like a separate thing. They're very related to the rules you already know. It's just like me saying it's the derivative of the outer with the inside left alone times the derivative of the inner.